Today I'm talking about electric field intensity. In previous section, we are talking about Coulomb's law. Coulomb's law is the force between two separated charge. We have Q1 and Qt, and we want to know the force exerted on Qt by Q1. The direction of the force is from Q1 to Qt. This is called R1t vector, and the unit vector of R1t vector is A1t vector. So we can find the force exerted on Qt by Q1 is F1t vector is Q1 multiply Qt over 4 pi epsilon 0. We assume this media is free space, so 4 pi epsilon 0 magnitude R1t vector square multiply A1t vector. So it can be Q1 multiply Qt over 4 pi epsilon 0 R magnitude of R1t vector square multiply A1t vector is R1t vector over magnitude of R1t vector. This is Q1 multiply Qt over 4 pi epsilon 0 R1 magnitude of R1t vector cubic multiply R1t vector. This is F1t vector. So when this test charge is 1 Coulomb, we called F1t vector is electric field intensity when test charge is 1 Coulomb, and this is Q1 multiply 1 over 4 pi epsilon 0 magnitude of R1t vector cubic multiply R1t vector. This is electric field intensity for test charge when test charge is 1 Coulomb by the Q1. It means Q1 cause the electric field for Qt is 1 Coulomb. So Q1 is called source, the cause of electric field, and Qt is field. Field is the range which this source affects electric field. So we summarize electric field definition for point charge. We have fixed charge Q1, so this is source, and unit test charge Q1, Qt, and Qt is 1 Coulomb. Whenever unit test charge Qt moves around fixed charge Q1, Qt got force due to Q1. Q1 is called source, and the range which Qt got force is called field. So Ft vector is Coulomb's law exerted on Qt by Q1. So this is Q1 multiply Qt over 4 pi epsilon 0 R square multiply AR vector. R is magnitude of R1t vector. Q1 is the source and Qt is test charge. The direction vector from Q1 to Qt is R1t vector. AR vector is unit vector of R1t vector. The magnitude is 1. And the unit vector is R1t vector over magnitude of R1t vector. So we can write Ft is like this. So when Qt is 1 Coulomb, Ft become Q1 over 4 pi epsilon 0 is multiply 1 R square AR. This is called electric field intensity. And field associated with change at general location. General location means the source point charge is not located at origin. For example, source is Q1 and test charge is Qt. When Qt is 1 Coulomb, the force exerted Qt by Q1 is called electric field intensity by Q1. So direction of electric field intensity is from Qt to Q1 to Qt. This is R1t vector. And unit vector of R1t vector is AR vector. So this is origin. This vector is position vector for source. This vector is position vector of field. RT vector is R1 vector. Generally, we write the position source vector is r vector prime. If there is a prime, this position vector is a source position vector. This is written by r vector. There is not prime. This position vector is field vector. The r vector is position vector for field because it is without a prime. Though there is a prime, this is position vector for source. This is with prime. So electric field intensity is source charge multiply test charge 1 coulomb over 4 pi epsilon 0 r square AR vector. It can be Q1 over 4 pi epsilon 0 amplitude, magnitude, r vector. R vector is field vector, r prime vector is source vector square AR vector. And this is Q1 over 4 pi epsilon 0 magnitude of r vector minus r prime vector cubic r vector minus r prime vector. But we have multiple point charge. When many source point charge exist, total electric field intensity is the sum of each field due to each source. For example, we have one source point charge this is Q1 is source and Qt is 1 coulomb as test charge. The direction of electric field intensity is from Q1 to Qt. This is R1t vector, and the unit vector of R1t vector is AR vector. Generally, position vector of source is R prime vector, and the field position vector is R vector. So electric field intensity is force exerted on 1 coulomb. This is Q1 multiply 1 over 4 pi epsilon 0. If this media is free space, 4 pi epsilon 0 and magnitude r vector minus r prime vector. This is field position vector minus source position vector square AR vector. AR vector is unit vector of R1t vector. This is Q1 over 4 pi epsilon 0 r vector minus r prime vector square. AR vector is r vector minus r prime vector over magnitude of r vector minus r prime vector. This is Q over 4 pi epsilon 0 r vector minus r prime vector cubic multiply r vector minus r prime vector. Second is two source point charge. Source point charge exists. Source point charge. We have source point charge Q1 and Q2, and test charge is Qt is 1 coulomb. This is origin. The field position vector is R1 prime vector. This field position vector is R2 prime vector. Field position vector is R vector. The total electric field is electric field by Q1 plus electric field by Q2. So this is Q1 over 4 pi epsilon 0 r vector minus r1 prime vector cubic r vector minus r1 prime vector plus Q2 over 4 pi epsilon 0 magnitude r vector minus r2 prime vector cubic multiply r vector minus r2 prime vector. And generally speaking, we have n source point charge. Point charge exists. Total electric field is electric field by Q1 plus electric field by Q2, electric field by Q3 plus electric field by Qn. This is we can use sigma from m equal 1 to n. Qm multiply 4 pi epsilon 0 magnitude field vector minus source vector square AR vector. This is the total point charge. Total point charge is the sum of electric field for each source. This is total electric field. And we take an example. Find electric field intensity at 1,1,1 caused by 3 nanocoulomb. This is field coordinate. And 3 nanocoulomb is the charge quantity of source. So the source coordinate is point A, point B, point C. So we have 3 sources. This is QA, QB, and QC, and QT is 1 coulomb. This is origin, and this is RA prime vector. This is RB prime vector. This is RC prime vector. This vector is field vector is R vector. The total electric field is electric field intensity by QA plus electric field by QB plus electric field by QC. So we can calculate this. First, we calculate electric field intensity by QA. This is QA over 4 pi epsilon 0 source vector minus field vector cubic and source vector minus field vector. So we have already known QA is 3 nanocoulomb, 10 to the power minus 9 coulomb, and R vector is 1,1,1 is AX plus AY plus AZ, and RA prime vector source position vector is 1,1,1 is AX plus AY. So R vector minus RA prime vector is AZ vector, and R magnitude of R vector minus RA prime vector is square root 1 square is 1. So electric field by field intensity by QA is 1 over 4 pi epsilon 0 QA multiply R vector minus RA prime vector over magnitude of R vector minus RA prime vector cubic. So 1 over 4 pi epsilon 0 is 9 multiply 10 to the power of 9 multiply this is QA is 3 multiply 10 to the power of minus 9 multiply RA minus RA prime is AZ vector. This is 1. So this is 27 AZ vector. And second is electric field by QB. Electric field intensity by QB is QB over 4 pi epsilon 0 field vector minus source vector cubic multiply field vector minus source vector. So QB is same as QA. It's 3 multiply 10 to the power of minus 9 coulomb. Nano is 10 to the power of minus 9. And 1 over 4 pi epsilon 0 is 9 multiply 10 to the power of 9. And R vector is AX plus AY plus AZ. The field position vector. Source position vector RB prime is coordinate of point B is minus 1,1,0. So minus 1,1,0. So RB vector minus R vector field vector minus source vector is 2AX plus AZ, right? So this is the magnitude of R vector minus RB prime vector is square root 2 square plus 1 square is square root 5. So this is 9 multiply 10 to the power of 9 multiply 3 multiply 10 to the power of minus 9 multiply 1 over magnitude of r vector minus rb prime vector cubic is 5 square root of 5, and r vector minus rb vector is 2ax plus az. This is 27 or 5 square root of 5 2ax plus az. So we have to find electric field intensity by QC is QC over 4 pi epsilon 0 multiply magnitude of r vector minus rc prime vector cubic multiply r vector minus rc prime vector. QA, QB, QC is the same, and QC is also 3 multiply 10 to the power of 9 Coulomb, and 1 over 4 pi epsilon 0 is 9 multiply 10 to the power of 9, and r vector is, field vector is ax plus ay plus az. Source vector rc prime vector is coordinate for point C is minus 1 comma minus 1. So this is minus ax plus ax minus ay. So r vector minus rc prime vector is 2ax plus 2ay plus az. Correct, 2ax plus ay plus az. Magnitude of r vector minus rc prime vector is 3. So this is 9 multiply 10 to the power of 9 plus 3 multiply 10 to the power of minus 9 multiply 1 over 27 and 2ax plus 2ay plus 2az. This is electric field intensity by QC. So total electric field is electric field intensity by Q1 plus electric field intensity by Q2 plus electric field intensity by Q3. The electric field intensity by Q1 is 27 Az plus electric field intensity by Q2 is 27 over 5 square root of 5 2ax plus az plus electric field intensity by QC is 2ax plus 2ay plus this is az, that 2, this is az, and unit is volt per meter. This is the answer for this question. So today we are talking about electric field intensity. What is electric field intensity and how to calculate electric field intensity. Thanks for watching this video and see you next time. Bye bye.